We shall now talk about distributed operating system, multi-threaded operating system, and network operating system. Let us say we have 100 very powerful machines capable of doing different things. Let us say 10 machines are capable of processing video fast, 10 machines are capable of processing audio fast, another 10 machines are capable of processing the normal calculations very fast, and so on and so forth, all the way till 100. So all of these are separate autonomous or individual computers. Now they have the ability to talk to each other and communicate and cooperate because they are connected through hardware, cables or wireless, and through software interconnection. This software interconnection is managed by the distributed operating system. What a distributed operating system does is, let us say I have to submit a work where my video has to be processed. It will look at which of those 10 machines has relatively less load and pass on that particular processing to one of those 10 machines. So the load is uniformly distributed across different computers on that distributed operating system network. So we can assume that there are n number of computers. In my case, n happens to be 100 computers in the distributed operating system. The job of a distributed operating system is to ensure that the load is equally borne by different processors, IO devices, memory, etc. Not just one set of machines are exhausted and overloaded and the others are ideal. It ensures that all the resources are used uniformly and effectively without overburdening one and underburdening the others. This process of balancing the work, balancing the load, and managing the resources is unknown to the user. The user is not responsible for submitting it to X machine or Y machine. The operating system automatically takes care of handling which particular resource should handle this given work. A good example of a distributed operating system is an ATM. Okay, ATM is a good example where works on the principle of distributed operating system because it is taking certain amount of the load or processing on itself. Now, let us try to understand what is this multi-threaded operating system. So in order to do that, let's first try to get a conceptual grasp of what is a thread. Now let us say I have a 10 into 10 matrix. I have two 10 into 10 matrices. I am going to add matrix A with matrix B. Here, if you look at it, the addition process is the same for every row and column. So what I can do is I can break down this program into 10 different threads or parts where I can parallelly do the addition of those 10 rows at the same time. So row 1 is being handled by one processor, row 2 by the other processor, row 3 by the other processor, row 4 by somebody else, and so on until row 10. The advantage is theoretically the execution of the program now is 10 times faster. So a thread is the smallest sequence or the smallest group of instructions in a program that may be executed. Now in my process, the example I give you, you can think of it as consisting of multiple yani 10 threads. So each of this thread uses the same code for addition. Although the data items are going to differ because each row may not have the same data item, but the logic to add data in each row is the same. So it may share the same code and it will share resources. That means it is still using, all these threads are using the same memory available in the operating system. Now the advantage of threads is certain parts of the program, not every part of the program can be executed concurrently or parallelly. For example, when I am entering data, the data is going to be entered sequentially. You're not having 10 people enter the data at the same time. It is one person entering the data at a time. But while adding, I can add 10 rows parallelly. So that is what it permits concurrent execution of the program. Today, multi-threading as a feature is incorporated into most operating systems. Almost all of modern operating systems like your Windows 10 or 11 which is coming up, Unix, Linux, all have a facility for multi-threading. So thread is breaking down a program to facilitate, you can think of in your terms, parallelly parts so that the executional program is speeded. So they may use the same code, resources like memory, but it permits concurrent execution of different program parts. Think of addition of matrix as an example of a thread where 10 rows are added in parallel because all of them do not interfere with the addition of the rows of the other matrice. So you can parallelly add them. Now, let us talk about one last type of operating system, which is known as the network operating system. Okay, network operating system was very popular when we just started, or when you go to companies, you will be using invariably using the network operating system. The advantage of a network operating system is individual independent computers are connected to each other through cables, okay, and software. They collaborate through software and hardware. Protocols means you can think of them as certain rules, because when you are communicating there has to be certain rules to be followed so that you are able to work together. So network operating system impose certain rules so that computers or hardware devices can collaborate with each other. In a network, even a printer is treated as one node. A scanner can be another node. So suppose there are 100 people and working on 100 computers, you do not need 100 printers and 100 scanners. You can just have one scanner and one printer. Whoever requires the use of the printer and the scanner at that particular point of time, he or she can give a command and utilize the printer or scanner. The interesting thing about this network operating system is every user is aware of other machines or nodes in the network. So in order to use the facilities of the network operating system, the users have to log into the machines. They have to log in, be connected. They have to log into the network. That means they have to sign or get into the network. And once they log into the network, they can copy files, they can submit programs, they can take files from others, they can pass files to others, they can give some jobs to other machines for execution, and so on. The advantage of network is, as I told you, you don't need 100 printers and 100 scanners. It facilitates resource sharing, reduces costs, ensures effective utilization of all the resources. But when you have a network operating system, you need to have authentication and access control so that only people who are part of that network are able to access, log into the network and utilize the services provided by the network operating system. Examples of network operating system are Unix, Novel NetWare, Microsoft NT, and Cisco operating system.